I would like to continue the previous video on classes of operation for radio frequency power amplifiers and discuss just a little bit more about these various amplifier classes, Class A, AB, B, and C. Please watch the first video in this set for radio frequency power amplifier classes so that you know a little bit about what's going on with the bias under no signal conditions and how the waveforms are affected by these various classes of operation. I mentioned at the end of the previous video that you will not see Class C operation used with amplitude modulation old-fashioned AM. Well, that's not strictly true because there is an important exception and a trick, as it were, that has been used ever since radio frequency power amplifiers and amplitude modulation existed. More commonly done in the old vacuum tube era than it is now. In fact, old-fashioned AM is pretty much confined to the shortwave radio broadcast bands and the standard AM broadcast band, the old-fashioned standard AM broadcast band. However, you don't want to use Class C operation with an amplitude modulated signal at the input of the amplifier itself in an attempt to amplify the envelope along with the waveform. However, if you apply the audio for a Class C amplifier to the plate of a vacuum tube Class C amplifier, you can, in fact, get away with it. Well, why would we even want to use... The reason that you can get away with it is a little bit complicated, but the Class C amplifier itself only amplifies the carrier wave in a plate modulation arrangement. You literally force the output to change amplitude by applying a high-powered audio signal to the plate or the output of a vacuum tube circuit. In order to do that, you need a lot of power in the audio, and it's rather wasteful, but it does work, and you can get away, therefore, with Class C operation in old-fashioned AM under that unique state of affairs. But that's not done so much anymore. With single sideband, no. Class C operation, you really can't do that because it will distort the modulation envelope significantly. So now you may wonder, why on earth would we ever want to use any amplifier other than Class A? Because if you'll notice, it appears that we're getting less amplification for a given amount of driving power as we move down this curve. And that is, in fact, strictly and theoretically true. In fact, if you reverse bias a device enough with a given amount of driving power, you won't get any output at all. But, of course, you can drive the device harder and force the device to go into conduction during part of the signal cycle. You just keep driving it harder and harder and harder. And even in Class C, then you can get output during part of the signal cycle. But still, the actual amplification factor in Class C is not going to be very great. Class B, it's going to be a little better. Class AB, a little better. And Class A, that's where you get the most actual gain or amplification. Well, that's cool in the case of weak signal amplifiers. You always want those to be Class A in radio frequency or audio frequency applications, because that's the way that you can get the most gain. And even a very weak input signal, you can still get that gain. You can still get the amplifier to do something. In classes B and C, a weak signal, you're going to get dead air, as it were, in the output, it's just not going to work very well at all. So why would we want to use class A, B, or B or C? Well, the secret lies in the efficiency, sometimes abbreviated EFF, usually expressed for amplifiers as a percentage. As things work out, if you provide an amplifier with enough drive, Class C ends up being the most efficient in terms of the actual usable power output divided by the DC power input. Now, DC power input is not the same thing as the signal power input. The DC power input is the product of the collector current and collector voltage in a bipolar device. In the case of a field effect transistor, it's the product of the drain current times the drain voltage. So that is the DC power input. What you want to do is make sure that you get the largest amount of useful signal output divided by DC power input. That is the efficiency. It's always going to be less than 100%. But in the case of a Class A amplifier, you're going to be lucky if you can get 40% efficiency. Class AB, you might get 50%. Class B, sometimes you can get up to 60%. And in Class C, you can sometimes actually get up to 70% efficiency. Well, that's a little bit of a yes and no, in and out kind of situation, because you're talking about the efficiency in terms of the useful power output divided by the plate power input. But in order to make Class C work at all, you have to drive the daylights out of that amplifier. And in order to do that, you need more power from the driver. So, in a way, as we might say here in America, you're robbing Peter to pay Paul, or the right hand is taking away from the left. So you never get something for nothing. You never get a free lunch. Nevertheless, Class C operation is used, and it is quite efficient, and one of the main reasons to use Class C is because the fact that you get more useful power output for a given amount of DC power input means that the device is going to dissipate less heat. The final amplifier circuit, or the power amplifier circuit, will dissipate less of your power as heat, so you can actually use a higher level of actual output power in a Class C amplifier than you could do with Class B or Class AB or Class A. You will rarely see, by the way, Class A used in an RF power amplifier. Audio, yes, you will see that, but not in radio frequency applications. So that's a little bit more about why you would even want to consider these other classes of operation. They have less gain, but they have higher levels of efficiency.